problems, so I'm just going to do answers with only a little bit of explanation so that you can check your work. We already made this area model in class, but let's remember that we have 2 dice. We have dice number 1, and then we have dice number 2. And then each dice has 6 sides. So we're going to have 6 rows for dice number 1, and we're going to have 6 columns for dice number 2. Let's just go ahead and make those. So there are 6 columns, and then we need 6 rows. 1, 2, 3, 4, 5, and finally 6. Usually when we're doing dice number 1 and dice number 2, we label these 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. In this case, we have some unusual dice. Dice number 1 actually has a 1, a 1, a 1, a 2, a 3, and a 4 as the sides. Dice number 2 has a 1, a 2, a 2, a 2, a 3, and a 4 as the sides. I'm not going to go through and label all the squares. I would expect you to do that. However, honestly, it's just difficult for me to write in with the pens. But just so, for example, we would label this square row 1, column 3. So that represents rolling 2 dice and getting a 1 and a 3 on the first and second dice. For our probability distribution table over here, probability distribution tables is where we have 2 columns. One column is our probability, and then our other column is usually found in the reading. In this case, we want to find a probability for the sum of the numbers of the dice. So here we're going to label sum. What can the dice add up to? Well, if we look at all our squares, some of them add up to 2, some of them add up to 3, some of them add up to 4, 5, 6, 7, and then I think 8. Hopefully you can see it down there at the bottom of the video. 8 is the biggest dice that they can add up to. Our dice stop at 4 and 4, so they're never going to add up past 8. Our probabilities, I've already kind of worked this out in advance, so I look for all the squares that add up to 2. There are a total of 3 squares, all these 1s that add up to 2, so there's 3 out of 36. How many of them add up to 3? Well, there's significantly more. There's about 9 right here that are 1, 2. Plus there's a 2, 1 down here. So it should be, if you counted correctly, 10 out of the 36 squares. The 4s, there are 7 out of 36 squares that add up to 4. The 5s, there was a bunch of 5s. I think there was 8 out of 36. How many added up to 6? There are 5 out of 36. How many add up to 7? Oh, there's not many. There's only 2 out of 36. And then how many add up to 8? Only 1 out of the 36. That 4, 4 square down here at the bottom right. Okay, so that's A and B. I think the big thing I want to emphasize in A is if you have to make an area model or you have to make a chart like this, you always want to think, if I have 2 dice, dice 1, dice 2. If we have 2 people, person 1, person 2. If we have 2 classrooms, classroom 1, classroom 2. And that'll help figure out, once we kind of know what we're labeling the rows and the columns, it helps us depict kind of the specifics for the shape. And then probability distribution tables. We haven't done many of those since spring break, but that's just where you have your columns and you figure out the probability for each specified result. So in this case, we're looking at probabilities for different sums. All right, for the next C, D, E plus number 2, go ahead and click on the next video.